Righto, so let's answer some questions. Just move this out of the way. Your answer should be concise. Aim for 1 or 2 sentences. What does the if selection statement do? Oh, what does the if selection statement allow a program to do? So, and you can speak if you want to, and otherwise type it into the window, and I'll repeat what you say. So, what does the if selection statement allow a program to do? What's the point of it? Why have an if selection statement? Yes, that's right. It's all to do with conditions. So it's all to do with conditions and branches. So you can have different paths through your code or different processing depending on the values of data, or yeah, we'll stick with data for now, or the date time, or various other things as well. So you know different branches through your code depending on the values of certain data. Okay, so you can allow your program to do flexible things like if it's a Monday, you might want to do the payroll processing. If it's a Tuesday, you might want to do the give employees a raise processing, that sort of thing. So you can do different things depending on the values of the other data items. What is an import declaration and where does it appear in the top of a Java source file? So what is an import? Why have one? And where does it appear? So why have one? And where? Anyone got any answers on that one? Yep, so that's where it goes. It goes before the start of the class. Yep, so before the public class statement. Why have one now? What's the point of having them? Okay, so it's to bring in extra functionality. It's included in Java by default. Okay, so for example, dates aren't included in Java by default. So if you do an import for Java util date, you can bring in a date functionality. If you need to get user input from the user and you're running a console program, you could bring in scanner, and that lets you get input from the keyboard. So you can do an import for Java util.scanner. And until you did those imports, you couldn't use that functionality. So it's bringing extra functionality from Java. It's included in Java, but not included automatically in your programs. Okay, and there's a whole bunch of stuff we'll be bringing in later. For example, when we're doing GUI development, we'll be bringing in labels and buttons. But for now, we've been using scanner, and a little bit of date, and they're the main two we've been using so far. Okay, the next one. Why does a semicolon cause a logic error if placed immediately after the right parentheses in an if statement? So let's do one. If age is equal to 30, semicolon, system out dot println are 30. So is that a logic error or is that a syntax error? It is a logic error. It is a logic error. Okay, that's good. Sanjin and Callum's got it. So your code will still compile with that there. Okay, your code will compile. Java will run your code. Java assumes you. That's right. It does end the if statement. That's exactly right, Andrew. It does end the if statement. So you might think that if statement ends here, but it actually ends here because there's a semicolon there. So no matter what value age has got, you will always see that on the screen. Okay. Just a second, everyone. I've just got to pause for a second. Just got someone at the door. Just a second. Bella, Bella, shh. Bella, Bella. Stop, stop. Bella, she's got to have the last say, that little pooch. That's my little Bella. You'll see me use her in a lot of examples in class. she's a beautiful little doggy. Okay, so if with the semicolons there, that ends the if statement. So this code here will always run no matter what. Okay, so it's a logic error. Your code still compiles. Java doesn't produce any errors. Java just assumes you know what you're doing. So that's a logic error. So what does it cause a logic error? And the reason is because any code that you thought was included in the if statement is automatically run no matter what value the if condition produces. So whether that's true or false, this code here always runs, whether you got parentheses or not, whether you got curly brackets or not. Okay, any questions on that one? So you got to watch your semicolons. That's a logic error. Okay, so don't put that semicolon there. Okay, so an import declaration. So we just got a question there from Klein. What's an input? It's all to do with bringing in extra functionality. Okay, that's not included in your Java program by default. So it's a whole lot of stuff included with Java. Some of it's included by default. For example, we can declare integers and doubles and chars and things like that, and we can work with strings. But there's not much else. We can do system out print lines, but we can't get user input. We can't work with dates. Okay, so we need to do imports today. So we do an import for scanner class, the Java util scanner, and that brings in the scanner class so we can get user input. And we can bring in the date class, Java util.date, and it will bring in the date class, and then we can get work with dates. Okay, and later on we'll be doing imports to GUI stuff like label. Oh, I've also done the J option pane as well for our input dialogues. So we've done those as well. So we've mainly done those 3 imports. Not so much on date, but definitely the other 2. But later on we'll bring in. Okay, cool. And where do they go? It goes before the class, before the public class statement. So when you're up the top there, usually I put a comment block at the top of my code, and then I do the imports and I do the public class. So that's sort of how I lay out my code like that. But you can actually put the imports up above your comment header if you like. Just looks a bit strange. It looks a bit strange to me, but okay. Question 2. For each program segment, read the code and write the output. So we're going to try and work out what the output is. And it says don't execute the program on a computer because we want to try and work it out ourselves without using a computer. You can, once you've worked through it on your own, you can definitely run it on a computer and check your results. But we just want to try and work it out in our minds first without using a computer. So what's the output of the following program for each of the input values? So let's do an input of 5. Let's start with 5. I'm missing some curlies. I copied these all from the PDF just a few minutes ago before class started, and so I didn't have to keep switching backwards and forwards. So we're just working on one page, not flicking around all over the place. Okay, so we're declaring a number. We're getting a number from the user. So that's our keyboard input object, the scanner object, and it's wrapped around system.in. Oh dear. Okay, kill that phone off. And so enter an integer. And then we get in that number from the user. Number equals input.nextInt. So that's our scanner object, .nextInt. If number is not equal to 7, print welcome. And if number %5 is equal to 0, print to Java programming. So this one's pretty easy, not equal to 7, as long as you know that that exclamation point means a not. But what about this one? What does the % sign mean? Does anyone remember? It's a very useful little operator, that one. The % sign, what does it mean? Modulo, that's right, Byron, well done. The modulo operator, so it's all to do with remainders. So if number %5 is equal to 0, it means after you divide number by 5, there's no remainder. So for example, 25, 5 goes into 25 5 times, no remainder. So that would cause that there to be executing that. Okay, let's just check our code to make sure there's no sneaky semicolons. There's no semicolon there in the if statement, no semicolon there. So there's no tricks in the code. It's just a straightforward program. Okay, so let's work through it with the number 5. With number 5, So is 5 not equal to 7? That's true, isn't it? That's true. And is 5% 5 equal to 0? So is 5 evenly divisible by 5? And it is. Okay, so 5 will produce welcome to Java programming. Okay, so the number 7. Is 7 not equal to 7? That's false, isn't it? Because 7 equals 7. So we won't see the welcome. And is 7% 5 equal to 0? So 5 goes into 7 once with 2 remainder. So that's not equal to 0. So we won't see 2 Java programming either. Okay, so for this time, we won't see anything on the screen at all if we type in a 7. If we type in 100, 100 is not equal to 7. So we'll see welcome. And 100% 5. 5 goes into 120 times with no remainder. So we'll see the to Java programming as well. And that's a print, and it's a print line. So we'll see it like this on the screen. There's a space there before the closing quote. So I'll see welcome to Java programming like that, all on the one line. Okay, and so on. So you can -7 is not equal to 7. It's not evenly divisible by 5. So we'll see welcome to Java programming. And 0 is not equal to 7. So we'll see the welcome. What about 0% 5? 0% 5. So 5 goes into 0 times with 0 remainder. The remainder is still 0 when you've got 0% 5. So even for 0, we'll see welcome to Java programming. Okay, is that okay for everyone? Everyone understand that one? Anyone not convinced? Okay, I think that's all good. There's no comments, so I think we're okay. We've got 14 people so far, 14 people, woohoo! Righto, question 3. Determine if there is an error, or determine if there are errors in this following program segment. If there is an error, specify whether it's a logic or a compilation error, specify the line number in the program, and write out the corrected code. Okay. If the code does not contain an error, write no error. There may be more than one error in the program segment. Okay, so have a scan of that code there and see if you can find any errors, logical compilation errors. And if you like, you can type into the chat window or turn your microphone on and say them. Okay, either way is fine. There we go. We've got Andrew, line 3, system.out.print. Line 3, Q is. No, that's not an error. That's okay. System.out.print. You can have print. There's print line and there's print. Print just means print out the data and leave the cursor at the end of that line, wherever the data ends. Print line means print out the data and then bring the cursor down onto a new line. Okay, so print's okay. Q is. Unless I don't think they want to output the value Q. I think I want to say Q is and then equal to 100 or not equal to 100. So I think that's quite okay. Logic error line 7. Yeah, we've got logic error. We've got the semicolon at the end. There's actually another error there. That's okay, Andrew. No, it's okay. Good guess. If they wanted to output the value, you would have been right, and that would have been probably a logic error, so you would have been right. But I think it's okay saying Q is because they're going to put the value there anyway soon. So I think that's right. Logic error line 7. If Q not, it should be not equal to. So that should be not equal to there. So that's a compilation error. That would be a compilation error. So it should be not equal to. So line 7 should be if Q not equal to, and know that. Specify whether it's a logical compilation, special line number, and write out the corrected code. So it doesn't explain, it doesn't ask you to say what was wrong, so we don't need to write out a bit of a spiel about what was wrong. Just write out the corrected code. So we've got a compilation. I'd probably write a bit of a spiel for this one to make it clear. Not equal. And sorry, shift key held down far enough. And logic error. That's the correct code there. So I fix line 7. Any other errors you can see there? There's one other. Line 5, that's right. Sanjin, that's right. What's the error? And is it a compilation? Ah, perfect, yes. So they've just used single equals. A single equal should be double equals. And would that be a compilation error or a logic error? You could be right. In C++, you would be right. It would be a logic error, but Java actually picks it up as a compilation error. So it is a compilation error in Java. Java does a bit more checking than C++. And the correct code should be if is equal to. Okay, that's good. I think we've got them all. I think there's only those 3 errors. Okay, so the next questions are question 4. Question 4 is the next one. Write an application which inputs 3 integers from the user and displays the sum, the average, the product, the smallest and the largest. So we're getting 3 integers from the user. I'm just going to sum them up, average them, product them, multiply them together, get the smallest and get the largest. The calculation of the average in this exercise should result in an integer. So in other words, we want if the sum is 7, the average should be 2, not 2.333. So it says do an integer calculation for average. Okay, so we'll do this program now. If you guys want to join along on your own, you can. Otherwise, we'll just work through it together on here. Public class. String, square brackets, args. Just do this, the usual template that said we start all of our programs so far. So that's just the usual thing. Now we've got to get three integers from the user. 3 integers from the user. So we need to prompt the user first. I wonder if it's going to be really slow if I ask people to type in the next line of code in the window. If you want to have a go. Does anyone want to type in the next line of code in the window? So we want to prompt the user. 3 integers, sum, product, smallest, largest, and display the results. Okay, so that's something we want to do. So we're up to this part at this stage. Does anyone want to tell me how to prompt the user for 3 integers? You can tell me speaking if you'd like. Or write it in the chat window, whatever you want to do. Yep. So yep, that's a good point to start. So we'll do an import for scanner. Java.util.scanner. And like I said, Java's highly case sensitive, so it's got to all be lowercase, uppercase S, and lowercase scanner. Okay, and a semicolon at the end. Okay, so now we can declare a scanner object and prompt the user. So scanner, and we'll call it KB. So anyone want to have a go at what we write next? How do we declare a scanner object? Because use scanner, perfect, yep. There's a photo finish between Klein and Byron, well done. In fact, you've written the code there, I'll just copy and paste it straight in. There you go, system.in. So we declared a scanner object. Now we want to ask the user to enter 3 integers, so we need to prompt them, so we need to give them a message. So system out.print. We can do print if you like, and it leaves the cursor at the end of the line, or we can do print line, and that means it drops down onto the next line, whichever way you prefer. I quite like leaving it at the end of the line, so it's where the user's typing at the end of the prompt. Enter 3 integers. Okay, and we'll call the first one system. System.in. Well done. Well spotted, Andrew. Yep, so we're missing an S there, system.in. Yep. Everything else is right, I think, yep. Okay, so we'll declare an integer, int 1, int 2, int 3. Let's declare our 3 integers. And now we'll get the integer 1 from the keyboard. And does anyone remember how to get an integer from the keyboard buffer or from the keyboard input? We're going to use our scanner object, so it's kb.something. But what do we type? Extend, perfect. kb.next int, and you've got to put round brackets after it because it's a method call, and then don't forget your semicolons. Okay, so next int, and we just do that for each integer. We'll assume the user's typed in 3 integers, and if they've typed in A, B, C, or anything like that, our program's just going to crash when we try and convert it to an integer. Our program will crash, but that's okay. We haven't done enough code yet to deal with validating data. Okay, so that's coming up soon. Okay, now we've got our integers. We can work out the sum. Who wants to tell me how to sum up 3 integers? This is the easy part. Sum is equal to something. And I'll get the product ready as well. Int prod is equal to, so if you want to tell me any of these, you can. How do we work out the largest? How do we work out the smallest? How do we work out the average? And it's an integer average. So int average equals, yep, sum is int 1, int 2, int 3, yep. So client's got that one. The semicolon on the end. That's good. Who wants to have a go at the product or the average? Or the smallest, if you can work out the smallest. The smallest is going to actually need some if statements. Yeah. Yep, cool. Oh, I think Klein did a bit of a typo there. So he typed that into the chat window. Yep, so int 1 times int 2 times int 3 for the product. That's right, for Byron. So just multiply them together. This one here we got, yeah, divided by 3. That's right, yeah, quite right. Yep, divided by 3. Now we've already got this actually worked out, the sum. So we just use our sum from up here. And it just makes our code a little bit shorter. A little bit short. Yep, perfect. I wouldn't say product equals sum divided by 3. That wouldn't work from Jared. Yeah, yeah, average. Yeah, so, sorry. Yeah, that's all right, Jared. Yeah, understand. It's a sum divided by 3. Yep. Okay, let's work out the smallest. Let's just assume it's int 1. Okay, we'll assume it's int 1, and we'll try and find if there's another smaller number. Okay, so if int 2 is less than smallest, then we've got a new smallest. And if int 3 is less than smallest, then we've got another new smallest. So we assume it's int 1, and then we try and find something smaller. If int 2 is less than the smallest, then we've got a new smallest. And if int 3 is less than the smallest, we've got a new smallest. Okay. We can copy that code and paste it and do the same thing with largest. Largest. Assume it's int 1, and if int 2 is greater than the largest, then we've got a new largest. And if int 3 is greater than the largest, then we've got a new largest. Okay, so this is all less than here because we're trying to find something smaller. This is all greater than because we're trying to find something bigger. Okay, so if you're okay with everything so far, is there any questions so far? So prompting for the user inputs, getting the integers from the keyboard, summing them up, multiplying them together. That's all product means is just multiply. Getting the smallest, getting the largest. and getting the average. And that's the integer average, which is what the question asks for. Not a bad idea if you do that sort of thing, to type their integer average, just so someone doesn't come along and correct your code later and go 3.0 and make that a double. Okay. If you want the integer average, it's a good idea to say that as a comment, just so people are clear you don't haven't made a mistake. And display the results. So that's pretty easy. System.out.println sum plus sum. Product plus prod. Smallest. Largest. Oh, wow. Largest and largest. And the average. It's everything. Sum, product, smallest, largest, average. Yep. And of course, this just is like fingernails on a chalkboard to me. I've got to neat things up. I can't help myself. So, and often I usually line up the brackets as well on this side, but I won't do that. I won't go that far. Let's run that and see. We're going to clean compile. Let's run it and see what the results are. So type in 3 integers. So let's type in 6 and 18 and 3. And we'll get the sum is 27. So 24 plus 3 is 27. The product is that. The smallest is 3. The largest is 18. And the average is 9. So 27 divided by 3 is 9. Yep. I think we've got the right answers there. Just a sec, there's someone moaning outside. Just a second. Oh, I don't know what it was. There's nobody there. Okay, back again. Righto. So, is there any questions on that question? Anyone got any questions about it or anything they're not sure of? Okay, that's good. Everyone's happy. 12:32. Just checking the time. Plenty of time. Question 5 is, write an application which inputs one number consisting of 5 digits from the user. So we want to get a 5-digit number from the user, and separates the number into its individual digits, and prints the digits separated from one another by 3 spaces each. For example, if the user types in that number there, it'll be 4 followed by 3 spaces, 2 followed by 3 spaces, 3 followed by 3 spaces, and so on. Assume the user enters the correct number of digits. So we don't need to do with statements to make sure they've entered 5 digits and make sure they're all digits or whatever. So just assume they've entered a 5-digit number. Okay, so get the number in, pull off the digits and put them back out again, separated by 3 spaces. So public class, just follow the same old pattern, public class. Public, static, void, main, string, square brackets, args. And so we want to get 5-digit number from user. Then we want to loop. Ah, okay, yes. So we could actually bring the number in as a string, and there's actually a nice little function called char@. So char@0 gives you the first letter of the string. Char@1 gives you the second letter of the string. We might do it a few ways then. We'll do it a few ways. Okay. So But there's also ways we can do it using our divides. Okay, so we'll do it two ways, but that's a good point. So loop and pull off digits, output separated by 3 spaces. Okay, so we've got a 5-digit number. Let's just assume it's a 5-digit number. The question said that's okay. Okay to assume that. For int k is equal to, we haven't done loop. We haven't done, have we done loops? Just gone blank. Yes, we have done loops. So k is less than 5, k plus plus. So k is our digit counter. Phew. Hang on a second. I don't think we have done loops yet. So let's just, I don't think we have done loops. Sorry. I was working on some other questions last night, getting ahead of where we are. And sorry. Yeah, some people know loops, engine. Yeah, some people know loops, but we haven't officially covered them yet. So I'll do the question without getting loops. So if we've got a 5-digit number, let's create a divisor. Equals and so we want to prompt the user to enter a number, system.out.println, enter 5-digit number. And we want a scanner object, so we need to do an import for scanner, import java.util.scanner, uppercase S, you can declare a scanner object. I should do that right at the top. Scanner KB equals new scanner system.in system.in. When it goes dark blue, you know you're right. Get our number, int num equals kb.next int. So we're getting the number from the user as one big number. So if it's 5 digits, we'll get 5 digits. Okay, and so if we've got so if we do this, if we type in 42,339 and we divide that by 10,000, what does that give us? It gives us 4, doesn't it? Okay, so 4 is the leftmost digit. And if we go that number, percent, what do we get? So 10,000 goes into 42,339 4 times with what remainder? What's the remainder? Anybody? So the remainder, it's not a trick question. The remainder is 2,339. Okay. So you can see if we divide by 10,000, we get the leftmost digit. And if we do the remainder, we get all the other digits, with the other 4 digits of the number. What if we take this 23,339 and divide by 1,000? What do we get? No, we're doing the divider at this stage, Klein. So we get 2. And if we do the remainder, then we get the 339. So do the remainder. we get the 339. Okay, so we've got the second digit out of the number. So by doing divides and then remainders, you can pull all the digits out of a number. No, you're right. No, you're right. We're all still learning. It's okay. It's okay. If we do 339 divided by 10, sorry, divided by 100, we get, and if we do 339%, 100, we get, so what do we get for that one, anyone? The divided by 1. We get 3. And the percent one with the remainder, we get the 39. So you can see we just keep going dividing and remaindering, We can pull off all the digits. Okay, that's a lot of work. Later on next week, we're going to be doing loops, and or might be the week after, and I'll show you how to do this in a much more compact form. But we haven't done loops yet, so I can't show you that just yet, really. Maybe I can show you. So let's create an integer called remainder. And we're just going to do this process. And int digit. Digit equals num divided by divisor. Divisor starts at 10,000. And this is a nice way you can write numbers too. So instead of writing 10,000 like this, you can put an underscore between them, and Java lets you do that. It just makes it easier for us to read the number. It's still 10,000. Java still understands that it's 10,000. It's still just a plain old number, but it makes it much easier for humans to read. That's a nice little trick there, to put underscores between numbers. Okay, so digit equals num divided by divisor. That should pull off the 4. So now we can print the digit. System.out.pout. Followed by 3 spaces. 1, 2, 3. I'm using a print there because we want to keep it all on one line. Okay, so we've got the digit there. Now we want to get the remainder. Same sort of calculation, but modulo instead. Okay, and then what we want to do is say divisor equals divisor divided by 10. We're reducing the divisor by 10 each time. So divided by 10,000 here, then 1,000, then 100. Okay, and then print out the digit. So that's basically what we want to do. You can do that 5 times now. Okay, that's 1. That's 2, that's 3, that's 4, that's 5. So once you've got the code written once, you can just copy and paste it if you want to. Okay, we haven't done loops yet, but I might even jump ahead and do a bit of looping in a second and just show you a more compact way to do it. Okay, so let's run this code and see what we get. And we'll type in that number for our test number. Ooh. 40, 42, 43, 40. So see, something's not quite right here. Let's just check our code. And we should have been using the remainder. Up here, the remainder should be set to num. Okay. Set remainder equal to num, so the whole number, whatever they typed in. And then we should be using remainder. Okay, not num, because the remainder's going down each time. Not num. So a little typo there. Because up here, remember, we're using the remainder. We're using that in the next part of the calculation. And then we're using that, the remainder, in the next part of the calculation. So I was going back to the original number all the time. So that was why it was wrong. So remainders all the way through. No numbers. That should be it. Control 2. 42339, and then we've got 42339 all separated by spaces. We've got the cursor ending up here. Print any key to continue. That's produced automatically by TextPad for us to hold the window open. But we can make that so it goes down on the next line if you want to, by just putting a print line at the end. print line. That just moves that prompt down onto the next line, so it's not part of our output. Control 1, Control 2, 42339, and there we go. So that's nice and neat. Now we haven't done loops yet, but what I might do is show you how we can compact all this code into a loop. I'll leave this code intact so you can still see it. Okay, so I'll just comment it out. Let's do a for loop. For int count is equal to 0, count is less than 5, count plus plus. So this loop here loops 5 times from 0 to 4 inclusive. But if you want to loop from 1 to 5, if 1 to 5 makes more sense to you because we're talking about 5 digits, you can do that as well. So you count is equal to 1, count is less than or equal to 5. Same thing, still loops 5 times. Then we're just going to copy this code here, Control C, and paste it in, and do a nice little bit of an indent, and we're done. Okay, so we reduced 5 bits of duplicate code down to 1. Okay, so no duplication at all. Let's run that, make sure it works. 42339. 42339. Okay, so we're getting the same output. Okay, so that's a basic intro to loops. We haven't done loops yet officially, but int count equals to 1, counts less than 5, count plus plus. This is a for loop. It's just a standard counting loop, and we're declaring an integer called count, setting it equal to 1, and that's called the initializer stage. So this, you'll see there's 2 semicolons in here. So there's the initializer part, and then we've got the condition, and the loop keeps looping while this condition is true. Okay, so while count's less than or equal to 5, the loop will keep going round and round and round from that curly bracket down to that curly bracket. Just keep going round and round and round while that condition is true. And at the end of each iteration of the loop, it will run this code, whatever's in here. Here we're just adding 1 onto count. We haven't actually, okay. We haven't done count plus plus yet either, sorry. So count is equal to count plus 1. It's such a common operation in programming that you can simplify it to count plus plus in many languages like Java and C++ and things. So, so count plus plus is just a shorthand for saying count is equal to count plus 1. So many things we haven't done. There's a real learning journey ahead of you. Okay, so count plus plus is just a shorthand for count is equal to count plus 1. We could write that in there if you'd rather. Let's do that. Okay, means the same thing. Count is equal to count plus 1. Type in our number 42339, and there's our result. So everything's working great. Okay, so you can use the longhand if you want, or we can use count plus plus, whatever you'd rather. So we've now sort of done a little bit of loops, which is maybe a little bit scary. Okay, so let's, is any questions on that so far? That's quite an involved question. Is there any questions? Anyone's got any questions or anything? Not sure of anything? Okay, I guess everyone's okay. Let's do it another way. Okay, so let's do it without doing dividers and remainders. I'll show you a really easy way to do it. If it was any data, it didn't have to be numbers, it could be strings or anything. I'll show you a really easy way to do it. So with the same loop again, and we'll get string num string is equal to double quote plus num. So we're just getting whatever value num's got and converting it into a string by going double quote plus. That converts, so number's 42339, it becomes a string 42339. Okay, no longer a number. Now I might go back to count. Because the first character in a string is 0, I could either do this, count minus 1. Okay, or I could start at 0 and just use count without going minus 1. But because we started at 1 here, I'll leave the count -1 there. So 0 is the first character, and 1's the second character, 2's the third character, and so on. Okay, so I'm getting the characters out of the number string. I'm using char at. So char at just returns the characters one at a time. Okay, so char at, when count's 1, count -1, 0, and char at 0 is the very first character. Okay, so this is an even easier way. We don't have to worry about dividers and remainders and things. Let's run that and see if we get the same result. 42339. Oops. Let's just put a blank line in between those two so we can separate them. Four, 2, 3, 3, 9. And you'll see we get the same answer. So this one's using the dividers and remainders, and this one's using the char at. Okay, so this one here will actually work for anything, not just numbers. It'll work for any string data. This one here only works for numbers because you've got to be able to divide it and do the remainders and things. Okay, so pretty big question, that one, really. Well, I think we spent about half an hour on that one, 20 minutes or so. Are there any questions on that one? I know we haven't seen loops, so if the loop scares you, don't worry, we're going to cover those properly in class. Okay. And there's other types of loops we'll cover as well. There's while loops and do while loops and things like that as well. So there's different types of loops. This is just a for loop or a counter controlled loop. It's probably the most commonly used one. While we're doing a quick intro to loops, what would happen if I did this? Okay, so I've taken out the conditional statement. So how long will a loop loop? Does anyone have a guess? Will it loop once? Will it never loop? Or will it loop forever? So there are the three options. It's A, B, C. Anyone have a guess? Nobody. Come on, someone have a guess. No, infinitely. Yes, nice one. Ah, okay. So we've got two possible answers there. Yes, it does loop infinitely. If there's no ending condition, nothing to tell a loop when to end, it loops forever. So it'll just be high on a screen, going across the screen over and over again. Okay. What about this one? So all of these parts of the loop, the initializer, the condition, and the iterator part of the loop, these are all optional. So you can actually have a for loop that looks like this. Who wants to guess what that does? How many times does it loop? Does it loop never, or once, or forever? Forever. Yep, just loops infinitely until you kill your program. It loops forever. That's right, Sanjin. Yeah, for sure. We've got a nice little shortcut there from Byron. So we looked at the count plus shortcut. I'll just show you some other ones. So these all are part of the question. So I'll comment all this out. It's just us working around down here. Okay, it's just us exploring things. So you can do count equals that, or you can do count plus. There's a shorthand we haven't looked at yet. Count equals count plus 1. You can do the shortcut where you use the plus equals operator, and that means the same thing. Count is equal to count plus 1. Okay, so it just means add 1 onto count. Or you can use the other shortcut, the good old count plus plus. All mean exactly the same thing, exactly the same effect. What if I had this condition? Count is greater than 5. Instead of less than equal to 5, count is greater than 5. How many times did the loop loop? Okay, so you've got to ask yourself, when is that condition evaluated? Is it evaluated before the loop runs, before the loop even enters, or or is it at the end of each loop? And we haven't done enough Java yet for you to know that, but it actually evaluates at the start of the loop. Okay, so if you put count equals 1, keep looping while count is greater than 5, it's never going to loop. Okay, so this code here will never run, and execution will just continue down here at the end of the loop, after the loop ends. Oh, okay. Yeah, yep. So there are other operators we can do here as well. Instead of count minus, if you want to count down instead of count up, as Byron says, you can, if you want to count down, you can go count minus minus, and that takes 1 off count. So we could count backwards. Okay, and that's like count minus 1 or count minus equals 1. They're all the same. I'll put them all in so you can see. Count minus 1, count minus equals 1. So there are shortcuts you can use for all of those. These probably wouldn't work anymore then because we're counting backwards. Oh, well, we go into negative numbers and we keep counting while it's negative. So, yeah. There's no count star operator. You can't do that. There's none of those. So if you want to multiply count by something, you could say count is equal to count times 10, or count is equal to count star equals 10. Okay, it's the same thing. Or you could say count star count. Count star equals count. Okay. So they're all the same count as count times 10. That does look funny though when you see it like that. That does look strange. Okay, so with our infinite loops here, so like this one. Again, so when we get to 2 billion and something, 2,200,000,000, whatever it is, the maximum size of an integer, it would just go negative. And there's nothing here to say exit the loop. So we'll just count up through all the negative numbers, minus 2 billion, 2 million thousands, or whatever. Finally get to minus 1, 0, 1, and then back up again and wrap again around and keep going. Just go through the whole integer space forever until somebody kills the program. Okay, because there's no exit condition. And same there, we just keep looping forever. It's a good idea if you do an infinite loop like that. Maybe put a comment on it and say infinite loop, just so people know it's not a mistake later on, or for testing or something like that. You do mean for it to be an infinite loop. Not a bad idea for dangerous code or code that does look. Why would someone put that in their program? Yeah. Okay, so do you need a break? So in the switch statements we saw in week 3's class, we needed a break to get out of the switch construct without executing all the other parts of the switch cases. You don't need that with for loops, but you can break out early. For example, if you did this, if you had this one, and if we're getting in system date, and if the date.getYear was greater than 2020, we could do a break, and that would exit the loop. Okay, and then execution would continue down here. So you can use break statements in loops to break out of them and get out of them. Yeah, it just means get out of it, go down there and continue on after it. So this assumes we've got the current system date. So we date equals new date, get the current system date time, and then check the year. And if it's greater than 2020, we're going to break out of the loop. So in other words, he's going to loop until New Year's Eve on 2020, until midnight. Okay, I think that's probably enough for those questions. If anyone's got any other questions, we'll talk about them. we might move on to doing some textbook questions. There's some good ones in there too. Righto. So we haven't officially done loops yet, but so I don't want to go too deep in the tute. But if you had nested loops, so we had nested if statements. If you've got nested loops, and there's code in there, whatever it might be, and code in there, whatever that might be. There's something in there and a break statement. It just breaks out of that loop. So it breaks down to there, and then it continues on there. So this outer loop keeps looping, and then next time through the inner loop starts again as well. So for each outer loop, the inner loop loops as long as it can, as long as it needs to, until the conditions say it can't loop anymore. And then, but here we can break out of it if we want to, but that just breaks out of the inner one, not the outer one. Okay, but yeah, we're getting very deep into loops there, where we are so far. Okay, let's have a look at some textbook questions. So Java programming, we've got, and I've got the old edition, the 8th edition, so on page 291 for week 3. 291 for week 3. Page 291. To do the revision questions, we'll do the revisions first to have a bit of a break. The logical structure in which one instruction occurs after another with no branching is a, does anyone have a guess at that? So just a logical structure in which one instruction occurs one after the other. No deviating, no conditions. What's that called? B, a selection? No, selection is when you've got conditions to branch. It's A, that's right, Andrew. It's a sequence. Okay, so it's a sequence. Just sequential instructions are just one after the other. Like sequential steps when you're stepping down the road. If you're not turning left and turning right, sequential steps, just keep going straight. Which of the following is typically used in a flowchart to indicate a decision? Okay. A diamond, that's right. So it's a diamond symbol that indicates a decision. Which of the following is not a type of if statement? We haven't called them this really, so this is not really a fair question. A single alternative if statement's when you got just if age is equal to 10 or something like that, just one alternative. The dual alternative is if you got if and an else, or an if and an else if and an else if, and so on. So C, that's right, a reverse if statement, that's right. That's right. Okay, a decision is based on something value. A decision is based on a something value. So when you've got an if statement and you've got something inside brackets that's getting evaluated, what does it evaluate to? A D, that's right. So it evaluates to Booleans. So 4D is the right answer. That's the one there. In Java, the value 14 greater than 7 is? It's true, yep. So that's true, A. Jared and Andrew are right on that one. Assuming the variable score has been assigned the value 13, which of the following statements displays XXX? So the value is 13 for score. And there might be multiple answers here. Yep, everyone agrees A so far. Sanj and Jared all agree A. Is there another answer? No, good, okay. Just making sure. Okay, that's good, well done. Okay, what's the output of the following code segment? So we're initializing T to 10. If T is greater than 7, do something. Andrew's got it right, so number C is right. Just look at the print statements. They're prints, not print lines, so they've got to be all on the same line. So the correct output's AA, BB. 3 A's, 3 B's. Okay, good. What's the output of this code segment? If set t to 0, if t is greater than 7, yep, d is nothing. That's quite correct. Oh, is it? Hang on. Check the code again. Yes. Okay. So you've got to be careful. There's no curly brackets after the if statement. So the if statement actually ends after that print line AAA. So that's where the if statement ends. Okay, so this is just, it's indented. It looks like it's part of it, but it's not actually part of it. Yeah, it's easy trick. Don't worry about it. It's easy trick. Okay, so look for your curlies. Indentation's just for us humans, not for the computer. Okay, so all we'd see on screen is B's, the 3 B's. What's the output of the next code segment? So T7 if T is greater than 7. Yep, nothing. That's right. So T is not greater than 7, so it's not going to go inside there at all. When you code an if statement within another if statement, the statements are nested. Nice. So number C is right, nested. When you've got one if statement inside another. The operator that combines 2 conditions into a single Boolean value, which is true only when both conditions are true, is the which operator? Yep, that's D. That's right. So Byron and Jared and Sanjin are straight on that one. So we've got the double ampersand is the one you want, this chap down here. When the operator combines 2 conditions in a single Boolean value, which is true when at least one of the conditions is true, it's C, that's right, it's the OR, the double vertical bar. Yep. Assuming a variable f has been initialized to 5, which of the following statements sets g to 0? So assume f's been initialized to 5, which of the following sets g to 0? There might be multiple. Yep, so A is definitely 1. B is definitely 1. And C, yep. So we also say D. That's right. That's all of them. That's right. Jared and Sanjin are right on that one. That's good. Which of the following has a these precedence ones? Look, I really don't think worry about them. The order of precedence, we're not even going to try and remember it, because if you put brackets in, you're forcing Java to evaluate things the way you want it to be evaluated. And then you never have to worry about the order of precedence. So assuming you use brackets, we're not going to answer the next one. Okay, so it's best always to use brackets to be clear. Which one it is? Look, to be honest, off the top of my head, I don't know. I'd have to look it up, because I never bother remembering the orders of precedence, apart from BODMAS. Because I always use brackets to force Java to evaluate things in the order I want. So yeah, best use brackets. Which of the following statements correctly outputs the names of voters who live in District 6 and all voters who live in District 7? So the names of all voters who live in District 6 or 7. So we haven't done really many if statements yet, but is that? Yeah, so this code here, you can do stuff like this in C++, where you use that shorthand, but not in Java. Java doesn't accept it. So B is correct, it's 6 or 7. And so this one here is not valid Java, number A. So B is the only right answer. And this one here, down here, if it's District 6, and if you've got a single equals, but even if it was a doubles equals, it still wouldn't be right, because it's District 6 and District 7. How could the number 5 be equal to 5 and 6 at the same time? So, yeah, so it's got to be the OR, and it's got to be using the right equals sign. So B's the right answer. Okay, so A is wrong because we can't actually use that shorthand in Java. Okay, you can't use that shorthand where you just say equals 6 or 7. It's not allowed in Java. Okay, C++, yep, that's fine, but not Java. Okay, Bit of a shame. It would have been a nice little shorthand to be able to use, but they didn't ever support it. So maybe one day. Which of the following displays error when a student ID is less than 1,000 or more than 9999? Less than 1,000 or more than 9999. So what do you think about this one? What sort of if structure is that? Number A, what sort of if structure? Yep, so it's a nested if. Okay, so this part here only gets evaluated if that part there is true. Okay, and can a number be less than 1,000 and also greater than 9999 at the same time? It can't. Okay, so if it's less than 1,000, it's not going to come into this part to see if it's greater than 9999. So it can't be. It'll only go less than 1,000. That's all it'll work for, and then it won't work for that either because it's not greater than 9999 as well. So A's definitely wrong. B there. Can a number be less than 1,000 and greater than 9999 at the same time? And it can't. Okay, it's one or the other. It's not both together. Okay, let's get into the next slide. If student number is less than 1,000, print error. Else, if student number is greater than 9999, print error. That one there looks pretty good to me. So I'll be happy with saying C for that one. Okay, good. Everyone else happy with that one? Any problems? Okay, number 17. You can use the something statement to terminate a switch statement. So Jared's just asked, if you rewrote this one to use a double vertical bar instead of ampersand, that would be perfectly okay. Yep, that would be correct then. So if it's less than 1,000 or it's greater than 9999, that's perfect. And that'll be a much better way to write it than this. This is horrible, really. Shorter, more concise code's better, much cleaner. You can use something statement to terminate a switch statement. What's the command you use to terminate a switch statement or exit out of a switch statement? Number D, break. That's right. That's the break statement. Nice one, Sanjin. Which of the following cannot be the argument tested in a switch statement? So I've got an old version of the textbook here. We can actually do strings now. Strings are allowed. So ints, chars, and strings are allowed. So if one of them is not allowed, it would be double, which is a bit surprising if they've supported strings before doubles. I'll have to look that up and make sure that's the case. But this is the old version of the textbook, don't forget. And back when the 8th version came out, string wasn't allowed. So I'll have to look it up and make sure on that one. But I think the answer is C for double. But they're adding more things into Switch all the time. It's changing every version of Java, or it seems to be so. So my answer there would be C for this stage. So with Java 7, strings became supported. So now Java 14 is about to be released. And there's a lot of changes since Java 7 and Java 14. They should say, as of Java 7, which of these is not allowed. Okay, but, yeah. Assuming a variable W has been assigned a value 15, what does the following statement do? So W has been assigned a value of 15, W equals 15, X equals 2, colon, X equals 0. So what does that statement do if W has been assigned a value 15? Aha, what does colon do? That's a good question. Okay, so we just talked about this briefly right at the end of the lecture on Wednesday. So this is a shorthand conditional statement. Some people like them, some people hate them, some people never use them. Some programmers use them for everything. Okay, so yes, so the right answer there is B. This is saying if W is equal to 15, set X to 2, otherwise, else, set x to 0. So it's like a compact if-else statement. If w equals 15, x equals 2, else x equals 0. So it's basically doing B, assigning 2 to x. Okay, so it's quick question mark just means evaluate. Is w equal to 15? Question marks. That's sort of making it sort of like it's English. So instead of saying if w equals 15 in brackets, it's using a really shorthand version. W equal to 15 question mark. Is that the case? If it is, set x equal to 2. Yeah. Otherwise, set x equal to 0. So it's like a shorthand. To be honest, I don't tend to use these very much. I've seen some people really abuse the hell out of them by making them do things they're not supposed to do, and so it turned me off using them. I've seen some horrible code. Horrible code. I don't mean from students, I mean from people in industry. I've seen some horrible code. Okay, the last one. Assuming a variable y has been assigned a value 6, the value of not y is less than 7 is. So start by looking at what's inside brackets first. Is 6 less than 7? That's true. So what's the not of that? What's the reverse of true? And that's D. That's right, St. John. It's false. False is the right answer. Okay, so when you see those exclamation points, exclude those. Look what's inside the brackets, and there could be a whole lot of stuff inside the brackets. Evaluate all that first, and then do the reverse of it. So false becomes true, true becomes false. Phew, we've done a lot today. It's been a good class. Still got 14 people here, which is great. Okay, so there's a couple of suggested exercises there as well. And I'd certainly suggest doing these as the minimum, question 1 and question 5. I recommend doing them all. Do all the questions at the end of each chapter as we go. Now, there is one thing I've noticed, there is a little issue. Bruce has changed the order that we do some things this term. So we haven't done loops and methods yet. That was part of chapter 3. And we jumped down to chapter 5 first. We're doing loops and methods next week. So some things are a little bit out of order to what the textbook needs. So some questions require prior knowledge that we don't quite have yet. Okay, so don't be put off if that happens. Just leave that question and come back to it next week or something like that. Okay. Whereas if you think you understand enough about loops and what we discussed so far, have a go at it. It doesn't hurt, does it? You can't. You can only learn. Righto. We've done date separator. We've done 3 integers. Let's have a look at our question 1. So write an application that asks the user to enter an integer and display a statement that indicates whether the integer is odd or even. I might just copy that into a text file. Copy it into a text file so we don't have to keep going back to it. And it's, oh yeah, I'll copy it onto chat as well. Here you go. I'll also upload all these worked examples to my GitHub as well as we go. So they'll all be on GitHub at the end. Give me about an hour after the lecture and I'll have it all done for sure. Okay, so it says call the application even odd. So public class even odd, even. Public static void main string square brackets odds. All the same old thing we've been typing the whole time. I've got public wrong there. I'll fix that in a second. Public. It didn't turn blue, so it's a dead giveaway. Okay, so we want to enter an integer. Determine if it's odd or even. Odd or even, and then tell the user. That's our pseudocode we're going to work on to solve this one. Okay, so get an integer from the user. determine if it's odd or even. So anyone got any ideas of how we can work out whether something's odd or even? It sounds really basic, but how do you tell if something's odd or even? Ha, perfect. Andrew was right on it. We're using the modular operator, the percent operator. If it's evenly divisible by 2, it's even. Okay, so using just good old modular to help us out. Okay, so we need import for scanner, import Java util, sorry, lowercase util dot scanner. Declare a scanner object, scanner KB equals new scanner system dot in. Yeah, probably sick of writing this one now. You've probably done quite a few system ins. Doesn't matter. It's all practice. Ask the user for input, system.out.println, enter an integer. Int num is equal to kb.next int. Get the integer from the keyboard. kb.nextInt, kb is our scanner object, wrapped around our keyboard or our default input device. And if it's odd, we might do this both together. If num, and as Andrew said, if num%2 is equal to 0, 0, it's got to be an even number. System.out.println. Else number is odd. If it's not even, it's got to be odd. And what if it's 0? Is 0 even or odd? So there are some numbers where we don't really. Maybe we won't worry about 0. Okay, let's run that. Ooh, public class. Should be declared in a file called even odd. Even. See, when I saved it with TextPad, see it's got .java. So it's got to save it again. File save as. Oops, not the tool output. Save that one. File save as. Got to make sure we select the right window. Even odd.java. That's better. Let's fix that up. Control 1. So you've got to be careful when you save it. Sometimes it does put the .java on the end of the .java that you've already typed. So Control 2. Let's type in a number. 63. And that's odd. 54. That should be even. Okay, so everything's working fine. Now, one thing, now that we've sort of had a bit of a play with loops, and we're going to be covering them soon anyway, let's say we make our program so that it just keeps asking us for input until we enter, say, 0 to quit. Okay, so I'll make that little change to our program. Okay, so basically what we want to do is keep running this code here over and over again until the user enters 0 to quit. Okay, I'll put that in there. 0 to quit. Quit. Or end, or whatever you want to say. So basically we want to put a for loop here. For. And let's use an infinite loop. Or yeah, okay, let's use an infinite loop just for the fun of it. Indent all that code. Okay, and then we'll test if num2 is equal to 0, then what do we want to do to exit our loop? We want to do a break, don't we? Okay, so we're in an infinite loop there and we're breaking out of it. Okay, so all of this is inside our loop. All of this code here is inside our loop. So it's going to ask for an integer, 0 to quit. And if we enter 0, it's going to break. Break means break out of our loop. Otherwise, it's going to come down here and determine whether it's odd or even. Okay, so we're just going to make it so it's going to ask us again and again until we enter 0. Let's give it a test. Control 1, Control 2. I'll enter the value 5. That's odd. 9 is odd. 8 is even. 0 is exit. Okay, so our program exits. So we've gone back to that precedent key to continue, which is what TextPad does for us when it runs our code. If you want to put a message out at the end of the program so that it's, you know it's exited properly. Have a nice day. If you want to put a blank line before that, fine. If you want to put a blank line after it, then /n. /n to put it onto its own blank line. So we could run it again. Control 2. 5 is odd, 8 is even, 22, 3 is odd, 9, 8, 4 is even, and 0 to quit. Have a nice day. Okay, so we just use a loop structure there to just keep prompting over and over again until we want to exit. Cool. 69. Do you want to run those numbers? Sanjay's put some numbers he wants me to run. It says 69. 69 is odd. 420 is even. Cool. Zero to quit. So the whole trick to the question anyway was going back to the basics of maths. How do you determine if something is odd or even? And it's really easy. Is it evenly divisible by 2 or not? And then you've got to remember, divisible by 2, what's the remainder, modulo operator? And then you're sort of home and hose for the question once you've worked that part out. Okay, so you can use infinite loops and they can do some good work as well. What if you didn't want to use an infinite loop? Okay, so if you didn't want to use an infinite loop, we could put this condition up here while num is not equal to 0. Okay, and then we'd have to declare num before the loop. Int num is equal to -1 or 1 or something, just something that's not 0, and keep looping while num is not equal to 0. And then we could take that out. Maybe we still have to do an if statement to make sure it's not 0 before we put out whether it's odd or even. So don't want to get 0 and then say it's odd or even. Okay, so it's not quite as clean. The infinite loop way is much cleaner, I think. If num 0, break, and you're done. Okay, you don't have to worry about filtering all this out depending on whether it's quick time or not. Okay, we'll leave that one, I think. Let's go to the next question that's recommended. The time for one more, probably. Question 5. Question 5 is a bit of a good one. Question 5. And it's to do with dates a little bit. Okay, and we haven't done much on dates. So let's learn. Okay, so I'll copy all that into a TextPad file. New. So it's got one Java, that's right. Also copied into the comments if you like. Okay. That's a big comment. Okay, so write an application that prompts the user for a day, a month, and a year, and displays a message that specifies whether the entered date is not this year, an earlier month this year, a later month this year, or this current month. Save the file as past, present, future.java. Now, we haven't done much on dates yet. We've basically just looked at getting the date today equals new date, and then you can display it to the screen and it will display the date. We could do that. Just do a quick recap of dates, just in case anyone hasn't seen that. I think we're going to choose java.util.date, uppercase D for date, public class past, present, future, public static void main, string, square brackets, args. Just a usual template that we start with every time. Should be getting pretty automatic at it by now, hopefully. Okay, let's just have a quick play with date. Before we go and answer the question, let's have a quick play with dates. So date today equals new date. So we're declaring a date object. We're calling it today. And then we can print it out to the screen. System.out println date today. So we're just printing out the current date object to the screen. So let's run that. And you'll see it saying Friday the 27th of March, Australian Eastern Standard Time, 2020. And the time where I am at in Australian Eastern Standard Time is 13:29 or 1:29 p.m. Okay. Don't we need to use scanner for input? Yeah, we're going to use scanner. We're going to use scanner. I just want to have a quick show how dates work first. Okay. Now, if we have a look at the date help in Java, and I've got a nice little compressed help file that I'll keep really handy, but you can also have a look in the Java help online. It's the same thing. This is formatted so it's nice and searchable. So date, and we're using the Java util dates. And you'll see down here, if we look at some of the methods that are available, that's how you can declare dates. You can pass in a year and a month and a date, or the day, and so on. And you can pass in long values for dates, which represent the number of milliseconds since 1st of January 1970. Okay, so you can construct dates in all sorts of ways, depending on what you want to do. And that's for maintaining compatibility with other systems and other ways of getting dates. Okay, so let's have a look down here. This is the interesting stuff. So get date returns the day of the month. Get date, sorry, returns the day of the month. Get day returns the day of the week. So 0 is a Sunday or something, 1's a Monday, something like that it is. This one here returns the actual day of the month. And you can click on it and see what the more information about. So I'll click on it and it will scroll down. And get date returns a value between 1 and 31 representing the day of the month, which is perfect. That's just what we want. So let's get today's day, int today equals today.getDate. We're calling the getDate function, and that's going to return the day of the month, 1 to 31, depending on the month. Okay. Then you've got to you can get hours and set hours. You can get minutes and set minutes. You can get seconds, set seconds. You can get time. We don't want any of that. We want, might scroll back to the top again because there's so many. It's easy to find them up here in this little table. We want to get the month and get the year. Get the years down here. So let's get month first. And that returns a value from 0 to 11. So 0 is January, 1's February, and so on. Why do they start at 0? It's just the way Java works. A lot of things start at 0 in Java. So let's get the month. Int month today equals today.getMonth. Now with this, look at the help again. And remember, it returns a value from 0 to 11. So we want to add 1 onto that to make it 1 to 12. So it's a proper number for a month that we use normally. So +1. Good idea to put a little comment there. So we got 1 to 12. Just reminding us before we add the 1 on. Even better. Okay. So with the day and the month and the current date, let's get the year. Today. Get year. And let's just make sure there's nothing sneaky going on with get year. Get year should just return 2020, shouldn't it? It should be pretty obvious what get year returns. This is Java we're talking about. Okay, let's make sure. So let's have a look at get year. We're not going to make any assumptions. Get year, get minutes, get seconds, get time. Should be coming up soon. I'm going to go back to the top again. It's easy to go back to the top of that little table because sometimes things aren't in the order you expect. Set hours, set month, set time, get year. I'm going to click on that. And that returns result that is the year after subtracting 1900. Wow. Okay. So it's only returning a year value after it's subtracted 1900 from it. Okay. So if we want to get the right year, we're going to have to add 1900. Okay, so it might seem strange, doesn't it? It does seem strange to have to do stuff like that. So you've got to read the Java help. You just can't call get year because we'll be getting something like 120 because it's taken 1900 off it if we're in 2020. We'll be getting a value of 120 and wondering why we're getting that value, why we're getting it. You've got to read the help. Okay. That gets us everything we need to do with dates. Now, one thing I will point out with a lot of these methods, see they're marked as deprecated, deprecated, deprecated. So deprecated means they're being phased out of Java. Ah, yes. So good point, Sanjan. It is related to Unix time. Yes. A lot of these things go back to Unix time and the way databases store time and things like that. So it is sort of historic that we're getting dates and getting these strange values back. Okay, so you've got to look at the help, read the methods, read what it's returning, and make the adaptation so you can get the answers you really need. Okay, so a lot of these methods are marked as deprecated, and that means being phased out. Ideally, you shouldn't be using them at all because they could be there in 10 years' time, they could be there in 50 years' time, they could be disappearing next year. You don't know. Okay, deprecated means it's going to go sometime. Okay, it might be 50 years, it might be 1 year, we don't know. Okay, so that's what deprecated means. You've got to be careful of deprecated methods. But this is just a tute question. We're not using this for a serious system that's going to be rolled out to a client. It's just a tute question. And we can get the year and month and day in other ways using other Java classes, but it's more complicated. So I'm just going to stick with get month, get date, get year. Okay, the simpler way to do it. And it's only a tute question, so it doesn't really matter. So let's go back to the question. Write an application that prompts the user for the day, month, and the year. Display a message that specifies whether the end of date is not this year, in an earlier month, in an earlier year, and all that sort of stuff. Okay, so we need to now prompt the user to get the system.out.println, enter a day of month, I might make all mine print statements so they're all, the cursor's waiting at the end of the line. Need a scanner object. I'll declare it up here, scanner, KB equals new scanner system.in. Now we need scanner, we need an import for that as well. So I could either add another one that says Java util.scanner underneath here, Java util.scanner, or else I could just make that an asterisk and bring in all of the util class. Some people are really fussy about their imports. I've got to say I am too. I like naming exactly what I'm bringing in. But for a tute question, it doesn't really matter. And we just bring in all of the class. It's going to result in exactly the same code either way. The good thing about doing it and dominating what you're using is it sort of tells when someone's looking at your code, they'll come to your imports and they'll go, okay, so they're doing a bit of date processing. They're getting some user input. You can tell. Whereas if it's just asterisk, what are they doing? I need to look at the code further. Okay, so it is sort of a bit of a documentation feature to name the packages you're bringing in. Enter day and month, enter month, enter a year, I might just say day, month, day, enter day. So int day is equal to the keyboard dot next int. The day from the user. We'll get the month from the user and the year from the user. Month and year. So we've got all the inputs from the user. We'll get the date and the month and the year from the system, and then now we've got the day, the month, and the year from the user. Now it's just a matter of comparing them and doing whatever processing is required. So let's scroll back up, and we'll copy and paste these down below so we can keep an eye on them. Okay, so there's 4 cases, and these will be good comments actually. Just make them comments. Three, four. So if it's not this year, so the year the user's entered is not this year. So we'll say if that's the year the user entered is not equal to the year today, or the current year. Maybe I should have called it current year anyway. Current day, current month, current year. Maybe I should have called it that. But anyway, I've called it year today and so on. So I'll stick with those for now. So if they're not equal, we can go system dot. Wow. system.out.println. I'll just output that message. Not this current year. Okay. And we'll do an else. And we'll keep all of this in the else. And usually once I put curlies here, I like putting curlies up above as well, even if it's only one line of code. Best to keep it all balanced. I like keeping it all balanced. Anyway, yeah. Okay, so if the years don't match, we're going to produce that message. Otherwise, if we're down in here, the years match. So now we're going to check whether it's an earlier month or a later month. So we'll check the month, the user month. If the user's month, which is that one, if the month is less than the month today, which is the current system month, then we can output that message, system.out.println. Let's grab that message. Okay. So if the month user entered is less than the current system month, then we're in an earlier month this year. We know the years match because we're in this part of the loop, part of this, the else structure. So we know the years match. So if the month is less than the current system month, it's got to be an earlier month this year, the user entered. Okay, now we're going to do part 3. Else, if month is greater than the month today, that's number 3 we're going to type out. 3, it's in a later month this year. Okay, so if the month's less than today, if the month the user entered is less than the system month, we're in an earlier month this year. If the month the user entered is greater than the current system month, we're in a later month this year. And the only other option is if they're equal, and that's this month. So this month. And that should be pretty close to being answered. Okay, so we've got all those cases covered now. We've prompted the user to enter a month and a day and a year, and we're displaying a message to the user which specifies which of those categories it is. Okay, so just a quick recap on the code. We're getting the current system date time, and we're getting the day, the month, and the year out of that. And the functions that Java has included can return some funny values. You've got to read the help on them to make sure you're doing the right thing and getting the right answers. Sometimes you might need to add some stuff on to get the right answer that you need. Just the way it works, sorry. And then prompt the user to enter the day, the month, and the year. And then check the years if they match. And if the years don't match, display that message. If the years do match and the month is less than the current system month, that message. Also, if the month the user entered is greater than the current system month, display that message. Otherwise, display that one. I think we're pretty well got it. Let's do a run and see. Ooh. Okay, so we've got the deprecated warning. So we're getting the message saying the get date in date has been deprecated. It's only a warning. It's not an error. It's only a warning. 3 warnings. Okay, and let me go up and kind of look at my preferences, tools. Now the reason why we've got those warnings coming out, I'll just take this out for a second. So normally when you set up TextPad, it doesn't have that in there. So I'll take that out again. And when you go to compile, it says, warning, you're using some overridden or deprecated API stuff. So something in the Java API you're using that's been marked as overridden or deprecated. Okay. And if you want to see what they are, you can recompile it with the -excellent compiler flag and to get extra details. So that's what we'll do. So we'll put that excellent flag in there, compile, preferences, and all you do is put it on your parameters line. Okay, so parameters is $file, uppercase F, $excellent, uppercase X, lowercase lint. Okay, and click apply. Click OK. Now when you compile with that, you get all the areas where there's anything that's Java's worried about. And we know what they are because we looked at the help and we saw they were deprecated. okay? But imagine this is thousands of lines of code, and a lot of it was something other people had written, and we didn't know what was deprecated and which wasn't, because we didn't know who'd written the code and what was going on. So that's when you want to turn on Excellent, and then you can have a look what's going on and say, so they're using some date stuff there and it's deprecated. This isn't an important application. We'll go with it for now. Okay. So I'll take that out again. So it does get a little bit annoying having Excellent turned on because you get all the messages coming out. In fact, I've got another compile down here where I'll get the Excellent stuff. Okay, so I've got another compile. So compile two ways. Control 1, Control 2. So I'm running it on the 27th of March. So let's enter the 27th of March 2021. So the years don't match. And oh, sorry, I entered the 3 numbers, and it's not this year. Sorry. Let's put some extra space and code in here. I forgot I'd prompt it for day, month, and year individually. Let's just do that. Control 1, Control 2, Control 2. Enter the day, 27th, the month, 3, and the year 2021. And it's not this year. Let's run it again. 27th, 3rd, 2019. Not this year. That's the easy part. Oops. 25th, so we're ending it a few days ago, 03rd, 2020, and it's this month, that's right. Control 2, 21st, 08, so we're entering a later month, 2020, and it's a later month this year. So it looks like our program's working fine. Okay, there's one more taste to test, and that's when it's an earlier month this year. 1/1/2020, an early month this year. So everything's working great. Okay, that's 1:47. We've done a pretty good solid 2 hours of work there. So don't forget, there's always extra textbook questions there in the textbook. You know, like I said, they might have loops, things we haven't quite covered yet, but just answer what you can, and next week you can come back and answer the other bits you haven't been able to do maybe. Or if you're feeling brave and you want to go ahead and push through with loops, have a go at doing it. You can't, you can only learn. You can't go wrong really. But lots of good questions there for, processing certain applications and doing certain things. So I hope that was useful. Any questions before we sign out? Anyone got any questions on anything we've done this tune? No, nothing, no questions, nothing in chat, nothing coming through. Okay, well, when are we going to go? Okay, that's a good question. When are we going to do GUI programming, GUI stuff? So when are we going to write nice applications with labels and buttons and not the nasty console applications? Well, we're getting onto that. We'll get onto that sort of later on in the term. And if we don't cover much of it later in the term, and there's some students that are keen, we can do some extra classes, and I'll do some extra videos for you to help you come up to speed on some GUI programming. Okay, so maybe not extra classes because we can't meet face to face, but I might do some extra videos for you. We come up to speed on GUI programming. Okay, so it is good fun doing GUI stuff because it looks nice and you can make nice applications. The console apps are so 1980s and 1970s. Still good fun. You got to be able to walk before you can run. So all the stuff we're doing is still highly useful. Everything we're learning is applicable to GUI programming as well. So it's just we're learning the basics first. Okay. Anyway, thanks for coming in, everybody. I appreciate you coming. Stay safe. Do lots of programming. Get lots of practice. Solve lots of problems. Explore lots of problems. Do lots of coding. And pretty soon, if it's not second nature for you, it'll become second nature if you do lots of practice. Okay. Anyway, thanks for your time. Thanks for coming. Have a nice day.